Hold up. Let me fix my stuff. I'm gonna call this that. All right, bet. I think we're good. I'm ready to go ahead and get started. Okay. So in this stream, bro, I don't know what to do since school hasn't started yet, and I don't know what y'all are doing. So I was just like, let me just remind people of how to factor because one, every single year, no matter what, it's always like the topic that students struggle with the most. Two, it's easy to forget how to do if you haven't done it in a long time. Three, it really doesn't matter what math class you're in, high school, even some college, you're gonna need to factor. So you just can't really get around it. So I was like, for those reasons, I might as well just kind of do a factoring stream. But before I just start cranking out problems, I was like, if I'm gonna do factoring, I'm gonna start like from the beginning and tell y'all what factoring even is, because I don't know that. Like, I know people who know how to factor, but I don't know for sure that everyone knows what factoring even is. So that's what I'm gonna start out doing. I'm gonna just define factoring, because it's a confusing word, low key. Because the word factor, it can mean a couple of different things. I'll show you what I'm talking about. So factoring, it's a okay. How can I say it like this? I'm gonna do it like this. I'm gonna say factoring verb. I don't know how dictionary notation works, so I'm gonna just do it like this, and hopefully that's correct. So it's a verb, so it's something that you do, and I'm gonna define it. I don't know how like math textbooks define it, but this is how I define it. Um, so factoring is a process. How do I want to word this? The process of, so you're not solving anything. You're not getting x by itself or anything like that. You are really just rewriting. Um, you're rewriting an expression. So I'm gonna do it like this. The process of rewriting an expression such that no. Yeah, such that. I like such that. The process of rewriting an expression such that sounds fancy. Such that it is the product of two or more factors. That's what I'm about to write. Uh, yeah, I'm gonna highlight that word product too because that's important. The product of, let's say, two or more factors. Two or more. Dang, I sound like Khan Academy. I see what he be talking about now. Okay, boom. That is my personal definition of factoring. The process of rewriting an expression such that it is the product of two or more factors. I like it. I like it. So here's what I'm going to do. I'm going to highlight some important words in that definition. I think this is also an important word. I want to do one more. Those are important, but I feel like based on experience, I want to let this be my third important word. So, why did I highlight these words? Because not everybody knows what these words mean. So I'm gonna do like a sub definition. Actually, I'm gonna start with I'm gonna just start in order. I'll do rewriting first. Why did I highlight the word rewriting? Just to emphasize the fact that you are not solving for X. In my past experience, people when they try to factor, they get confused with the directions and try to like get X by itself somehow. Not solving for X. And because I was gonna highlight expression too, these kind of go hand in hand because when you're factoring, it's not an equation, it's an expression. So you're not solving for anything. I'll also say should be no equal sign. There we go. I'm making sure I fit that in the frame for my TikTok viewers. All right, let me check the chat over here real quick just to make sure nobody said nothing. I need to figure out. E to the iPie. What's good? I was watching your stream the other day. Okay, I'm trying to make it to where I can get both of these chats on here at the same time. Hold on, give me 1 second. I think I can figure this out. Yeah, we'll make it work. All right, bet. So, what was I saying? Oh, rewriting. I just want to emphasize that you're not solving any equations. There should be no equal sign. The other important word is the word product. I would estimate that maybe 72% of people who end up watching this stream know what a product is. That's my guess. I'm going to define product as the result of multiplication. I seen those hearts in my peripheral. Whoever that was, I appreciate it. Okay, so product is the result of multiplication, which kind of leads into the third word, which is factors. Here's where it can get kind of confusing because I'm using the word factor to define factoring. So I get to the new learner how that can be kind of confusing. But remember, factoring is a verb. That's why I kind of tried to distinguish it. It's a process, so it's something that you do. But factors, the part that I'm highlighting, those are nouns or things. And they are things that get multiplied. So if you take two things and multiply them together, those two things are considered to be factors, and their result is called a product. So factors, I'm going to define that as things that get multiplied. And I probably could word it better than saying things, but for right now, I'm going to just keep it like that. Things that get multiplied. So I feel like that in and of itself is like worthy of stopping and like, I don't know, screenshotting if you're watching this and you might, find this of use. Because if you know, I will always say that if you know vocabulary, then a lot of the math just kind of like falls into place. You know what I mean? Like if you know what factoring is, then you know to an extent what you should do and what your answer should look like. So with that being said, we now know, actually, you know what, before I do, actually, no. Here's what I'm going to do. So I am going to get into some examples, but my first example is going to be super duper easy. It's not even going to have a factoring method associated with it. Everybody joining, appreciate the likes. Share this with somebody who's about to start class, because I know y'all probably didn't do math over the summer, and I'm willing to bet money that you forgot how to factor. So send this to somebody. But I'm going to do a super duper easy example of factoring just so you can understand the concept of what I'm trying to say. So let's just say I have, 15. And I was actually, no. Let me give directions. I'm going to say factor the expression 15, which is a weird looking expression, but I guess technically it is an expression. But to factor that based on our definition is we're going to rewrite that expression. So our answer is still going to be 15, but we're going to write it such that it's two or more things getting multiplied together to equal 15. Are we doing any Calc 2 soon? Yes, I need to make my schedule. Since class is starting, I'm getting my tutoring schedule kind of finalized. I need to schedule in a day of the week to do Calc 2. My idea is that every day of the week, maybe not every day, but each day will be like a different subject. But one of those will be Calc 2 / like linear algebra, something like that. But right now we're doing factoring. So I can have my expression 15. I can write it like this. All right. 3 times 5 would be my answer. Let me box it so y'all know that's my answer. But the concept of factoring is what I'm trying to illustrate with this first example. Notice how I didn't solve for anything. My answer is still the same or equivalent as my original expression, but this time it's just two things being multiplied together. So that is more or less what factoring is in a nutshell. Now, the reason factoring is so hard for a lot of people is, for one, I'll just say it, not everybody is that good with their times tables. Myself, well, let me not say myself included. I know my times tables, but I'll admit I could be better at them. So every year I always tell people when they ask me, like, how do I get good at factoring? I say first start out by learning your multiplication facts. It'll help you more than you think. But for that reason, I feel like a lot of students struggle with factoring. The other reason I feel like students struggle is because there are multiple methods to factoring. There's kind of a lot of them. Not gonna lie. So what I want to do for the rest of the stream is just kind of go over each method and talk about how to recognize the method. That's really what it is. It's not knowing the different methods. It's looking at an expression and being able to associate it with a certain factoring method. If I were to say so, I would say that's appreciate the follow. I would say that's the hardest part about factoring, is recognizing methods. My fault. I just seen your chat, E. I'm on OBS right now. For Twitch and YouTube, and then TikTok Studio for TikTok. But okay, so like I was saying, recognizing which method is the hard part, and I'm gonna just go over each method. First method, there's really no order. It's just covering all of them. This right here is the first method that I'm gonna go over. You have probably heard of this before. I will abbreviate it, but I at least wanted you to know what it stood for. And if you notice, the reason why I like doing this one first is because if you notice, greatest common factor includes one of the words that we just defined like a few minutes ago. So this is kind of an opportunity to see if you know what a factor really is. Okay, so my first example, I'll call it like 2A, I guess. Anything that starts with a 2, I guess, will be GCF. Now, I'm not gonna lie, I did get lazy, and is it lazy or efficient to have GPT pull up some problems for me? I'm gonna use some of theirs, and I'm gonna use some of my own. I'm gonna kind of start off easy so you can get the idea, and then we'll do some real problems. So for GCF, let's just do like let's do 12. I'm gonna do it in a different color. Hold up. Let's do it in green. Let's say I have like 12x minus 6. Let's just say that'll be our expression that we're going to factor. So the thing to notice is, like I said, knowing your times tables helps, because you're going to notice and observe that of these multiple terms, they have something in common. And in fact, that's always the first thing you want to look for whenever you factor, is of all your terms, do they have any factors in common? So x is a factor of this first term, but notice how my second term doesn't have an x. So x is not part of my common factor. You know, common means like something that they both have. So looking at the numbers 12 and 6, what I'm asking myself is there a number that can go into both 12 and 6? And ideally, I want to think of the biggest number that can do that. And so I did kind of start it off easy, but hopefully you notice that 6 can go into 12, obviously 2 times, and 6 can go into itself 1 time. And there's no bigger number that does that. So 6 is my GCF. I guess since I'm introducing, I'll identify the GCF. Okay, so my GCF is 6. So this is what it looks like to factor out a 6. So essentially what's about to happen is whatever my greatest common factor is, because remember, it's a factor, so it's getting multiplied by something as per our definition right here. So that 6 is going to be multiplied by some other factor to equal out to 12x minus 6. That's what I'm trying to do. So if my greatest common factor is 6, I know that I can write 6 and it be multiplied by something. And then whatever ends up being in that parentheses, that should come out to 12x minus 6. So hopefully what I'm doing is making sense. I'm trying to rewrite 12x minus 6 so that it is thought of as 6 multiplied by something, hence the parentheses. So from here, I always tell students you want to basically distribute backwards is how I word it. You want to distribute backwards. So, because if you can tell, this is kind of set up to distribute my 6. You want to ask yourself what needs to go in parentheses to where when I do distribute the 6, I get 12x minus 6. So I guess you can kind of think of it as like a little bit of backwards thinking. And so different people have different ways that they like to teach this, but this is how I like to do it. I just think 6 times what is going to give me 12x. Now, whatever it is, I know I'm going to have an x right there because 6 times a number is that result x. And so once I put my x in there, I really just got to ask myself 6 times what gives me 12. And that goes back to what I was saying about knowing your times tables. You would be surprised at how many teenagers and near adults don't know their basic multiplication facts. But that's all I'm going to say on that. So I'm not done, but as you can see, I can kind of check what I did so far and make sure that 6 times 2x is indeed not 12, but 12x. Okay, that is correct. And then if I want minus 6, I'm going to need a minus sign in there. And then I just ask myself 6 times what gives me 6. Well, you should hopefully know that 6 times 1 will give me 6. And so if you look, that's it. I know a lot of people, when they first learn how to factor, they wonder when they're done or if they're done. Remember, if you go back to the definition, you can tell that this is done because it's 2 things being multiplied together. If you are just joining, we defined factoring earlier. The process of rewriting an expression such that it is the product of 2 or more factors. And we did that because if you notice our final answer, hold on, let me box it. It has 2 factors, or in other words, 2 things that are being multiplied together. I will even highlight them for you. That is 1 factor. And let me use yellow. That is another factor. Those are 2 factors such that when I multiply them together, or in this case, distribute, I will get my original expression of 12x minus 6. So that is factoring. I did it kind of easy on purpose just so y'all can get the idea. If you're thinking, oh, this is easy, why do students struggle with this? I'll be honest, it does get harder, unfortunately. All right, but let's do another. So the skill, remember, is I call it observation skills and just looking at the different terms, which, by the way, I should have said this last problem, but I didn't. When I say terms, I'm talking about groups of expressions that are separated by a plus or a minus sign. So that last expression had 2 terms, which, by the way, makes it a binomial. But when I say terms, that's what I'm talking about. So what I was saying was you want to look at each individual term and ask yourself, is there anything that all of these terms have in common? That is your greatest common factor. So chat said this one right here. They said to factor 12, what did I say? 12x cubed plus 18x squared. I'm not mad at that problem. Okay. If you're just joining, I'm trying to remind y'all of how to do math by way of factoring. That's what all the problems in this stream is about, is factoring. If you're new to the stream. So far we've done GCF, and like I was saying a second ago, you want to look at all your terms. In this case, we only got 2 terms. And just ask yourself, is there any number or factor in general that both of these terms have in common? So, what I tell students when they're just beginning is if you see expressions with x's and x squareds and such, treat the numbers first and then treat the x's. And when I say treat, I'm talking about like look at the numbers and ask yourself, what is the biggest number that goes into both of those numbers? And so that really does stem from multiplication facts, I feel like, because if I just think about any number that goes into both, the first number that comes to mind is 2. I know 2 goes into 12 6 times, and I know 2 goes into 18 9 times. So 2 could be, it is a common factor, but I want to make sure it's the greatest common factor. So I'm checking. 3 goes into 12. Does 3 go into 18? 3 goes into what? 3, 6, 9, 12, 15, 18. Okay. So 3 does go into both. Is there anything bigger than 3 that goes into both? 4 does not go into 18. 5 goes into neither. 6 goes into 12 twice. 6 goes into 18 thrice. I don't know if you knew that was a word, thrice. So 6 is an even bigger common factor. Because remember, it's called GCF. We want the greatest common factor. So what do we say? 6? Is there anything bigger than 6 that goes into 12 and 18? 7 does not go into neither. 8 goes into neither. 9. Anything above that does not go into 12 nor 18. So number wise, we've identified that 6 is our greatest common factor. I can see students just mistakenly picking the first number that they think of that goes into both. But remember, again, we want the greatest common factor. So number wise, we said 6. So let me identify my GCF again like I did the last one. So I'll say GCF is, now remember, it's not just 6 because we have variables to worry about. So my first term, if you notice, it has an x cubed in it. So think of that as, actually, no, let me write it out. Don't think, just look at it. Watch how I write it instead. So instead of 12x cubed, actually a good way to write it would be like this. Instead of 12, because I already said that 6 goes into 12, instead of 12, I'm going to write it like this. I've never actually taught it like this. This actually could help. So I guess this is why they teach prime factoring. But I never teach middle school, so I've never done that before. But anyways, 12x cubed is equivalent to 6 times 2 times x times x times x. Hopefully I don't confuse anybody with this, but I'm just factoring out my first term. Upside down BTW, you like math? Bet. That makes one more of us. All right, so that's my first term, and then I'm going to go plus. And then instead of 18, I'm going to say 6 times 3. And then instead of x squared, I'm going to say x times x. I feel like if you break it down like that, it's a lot easier to see what these two terms have in common. Because you can literally see they both have a 6. Boom, boom. And then they both have at least 2 x's in common. The first term has 3 x's and the second term only has 2 x's. But at most, because remember, we're talking greatest, the most that they have in common is 2 x's, which is the same thing as x squared. So that right there, that 6x squared, that's going to be my GCF. So let me know if you're like following along, if that does or doesn't make sense. But okay, so now that I know my GCF, I can go ahead and factor. So I'm going to say, because remember, it's the product of 2 or more things. So my first product is going to be 6x squared. That's what's going to be multiplied by something. That's really the rest of this problem, is figuring out what goes in there so that when I distribute that 6x squared, I should end up with my original problem, which is 12x cubed plus 18x squared. Let me make sure I'm still in frame on TikTok. All right, bet I'm good. Okay, so again, times tables. That's always what I tell everybody. That's the best thing they can do for themselves is just get good at your times tables. Cause I mean I know we already factored it earlier, but had we not, we would have had to think 6 times what would give me 12, and you would see that that's 2. And then if you notice that I'm starting with x squared, I gotta go x squared times what to give me x cubed. And that's why I like the fact that I wrote it out, because you can see that my first term needs 3 x's, but based on what I factored out, I only have 2 x's. So I need to multiply by 1 more x. Like so. Ooh, I hope that makes sense. And then I'm going to go plus. And then I need to get 18x squared. So let's see. I already got my x squared taken care of right here. I just need to ask myself 6 times what will give me 18. And I believe 6 times 3 will give me 18. So again, let's check. So first of all, here's my proposed answer. Here's what I think my answer is. And then I'm not going to think that's my answer. I'm going to know that's my answer, because I be trying to tell students, bro, if you take a test that requires you to know how to factor, you should never get it wrong, because you can check your work by distributing and seeing if you get the original expression. So if I do my 6x squared times 2x, that's a 12. And then the x squared times x will give me x cubed. So that's good. And then when I distribute to my 3, that's a 6x squared times 3. That's an 18. And then it's still x squared. So that's what I have right there. So I literally just proved that I know that I factored correctly. Jaquez, what's good, bro? Okay. So that's the idea when it comes down to GCF. Again, there's multiple methods. Remember, this is only the first method. There are numerous methods. There's not a lot. There's like 4 methods, depending on what level of math you're in. But nonetheless, let's do like a couple more. All right, so chat gave this one next. Ooh, this is a good one. I think I didn't use chat. I used Copilot. I told it to make them progressively harder. So let's see. They said 8a squared b plus 20ab squared minus 4ab. Okay, boom. 3 terms this time, so I guess that technically makes it harder, not really. But same idea between all 3 terms, and there's 2 variables, but still, that shouldn't make it any harder. We are not doing SAT prep. We are just doing factoring. We are doing factoring, teaching and reminding and tutorialing, I guess you could say. GCF, there's 3 terms. Remember, do the numbers first, and then do each variable. So I'm going to do the numbers, and then I'm going to do the A's, and then I'm going to do the B's. So when I do the numbers first, when I say that, what I'm trying to say is between these coefficients, what is the biggest factor that they have in common? So I got to take a second to think about what that might be. So one thing I'm noticing is that all 3 coefficients are even. So that means at least 2 could go into all of them. But, okay, user, like I was saying on the last example, I don't want to just pick the first thing they have in common and run with it. I want the greatest factor that's in common. So 2 does go into everything, but again, you just got to know your times tables. 4 goes into everything as well. 4 goes into 8, 4 goes into 20, 4 goes into 4. Notice that your GCF could never be bigger than the smallest coefficient. No, you didn't miss much, bro. We just did GCF. It's that different, Metro. Going back, because it ended today, right? Battlefield. But okay, 4 is my GCF. coefficient wise. Now we got the A's to worry about. So in this first term, I got 2 A's, and then I got 1 A, and then I got 1 A. So at the most, they all have 1 A in them. I guess I'll use this opportunity to share. I had it's not an epiphany. I don't know what you call it, but I was at the gym, and it's a lot of strong people at my gym. And so I noticed when I was walking by the benches, it was 4 bench presses, like all right next to each other. And every person on the bench, I don't see this at like a regular commercial gym, I guess. Everybody had at least 2 plates on there. And so basically, it's like some people had more than 2 plates, but nobody had like under 2 plates. And so use that as an example of like what they all have in common. That's what I'm really trying to get at. So like my first term, you know how it's A to the second power or 2 A's? Think of that term as bench pressing 2 plates. And then these other terms, you see how it's just 1 A? Think of those as bench pressing 1 plate. So you can say at the very most, everybody on the benches, they can all for sure bench 1 plate. That is how greatest common factor works when it comes to variables. So with that being said, they all have at least 1 A. And then if I look, I guess I should highlight them again. That one has 1 B. I know this one has 2 B's. They can bench press 2 plates. But the first and the third term, they can only bench 1 plate. So at the very most, they can bench 1 plate or 1 B. That is the best way I know how to explain that. But all right, so that's my GCF. So now here's the easy part. If you know your times tables, you just write whatever the GCF is, and then you open up a pair of parentheses. This time, since I got 3 terms, I'm gonna make it. I'm gonna do it like that. And so I know before I fill in my answer, whatever goes in there, it should come out to this right here. AA squared B plus 20AB squared minus 4AB. All right, so again, I just think times tables. 4 times what will give me 8? 4 times 2 will give me 8. And then notice I already got an A, but if I'm trying to get A squared, I need an additional A. And then for the B's, notice I already got my B's, so I don't need to add another B in there. Otherwise, I would have B squared. So if I were to check as I go, 4 times 2 does give me 8. A times A does give me A squared. And then technically B times 1, not B times nothing, gives me B. So I'm good on the first term. And then I'm going to go plus 4 times what would give me 20? 4 times 5 is 20. Let's see. I already got my A because it was a part of my GCF. And then I noticed that I need B squared, but I already have a B. So I need to multiply it by a second B. That way, when I distribute, again, 4AB times 5B will be 20AB squared. And then last but not least, since I got a minus right here, I'm going to go minus. And then if you notice, in this case, I have everything that I need. I got a 4AB, and I'm trying to get 4AB. So what do I need to multiply by? 1. I need to multiply by 1 because anything times 1 is itself. Okay. I think I might have ran off the screen on TikTok. Let me see. I did. Oops. Hold on. Let me fix that real quick. And then I'm going to move on to a different method, low key. Because I feel like GCF is, I don't want to say self-explanatory, but it's like once you know how to do 1 or 2 of them, you should be good. Hold on, let me get this straight. Dang, I cannot get that on screen. All right, I think I should be good. Actually, you know what? I'm gonna do this, and then I'm gonna move on because I'm tired of trying to get this straight. Dang. Okay, this is too close of me not getting this rest of this line on the screen. Hold up. I hate that I'm like this. I'm going to do GCF with a colon, and then we're going to move on to the next question. Because I want y'all to be able to see what I'm writing. Okay, bet. That is perfect. I'm in. All right, next question. So, next method, actually. So, we're not even going to do GCF anymore. Next method I want to do, I guess we'll just do reverse FOIL. We'll do reverse FOIL. This one is, I would say it's easier, but only if you know your times tables. If you still struggle with that, this one actually might be harder in a way. But here's how this one works. I'm gonna just start off with my first example, because by now we should know that whatever expression I give you to factor, the result should be something times something. There will be, okay, I'll say this. There will be instances where your answer will have 3 factors, but for right now, all of our answers will just have 2 factors. So let's do this. I'll go x squared. And also I'm going to talk about how to recognize when to use this method versus like GCF. So let's say I do, let me think of a good one. Let's do this right here. Not a bad example. So we're taking, it's a trinomial this time. We got 3 terms, and we're trying to make it to where I can write it as something times something. So if I use what I know so far, remember I'll look at each term and try to get the GCF of each term. And this is what I was talking about when I was saying like how to know which method to use. You always want to try to find a GCF, but if you look at all 3 terms, there's nothing that they all 3 have in common. Yes, these first 2 have X's, but the third term does not have an X. So they don't all have an X in common. And then even number wise, 7 and 12, I don't even think those have anything. Well, I don't think they don't have anything in common. So there is no GCF. So right then and there, you know that GCF is not your method. Instead, what you do is you recognize that there's 3 terms. It's a quadratic. That matters. So we didn't really talk about that yet. Since X is being squared, that's what makes it considered a quadratic. I feel like that's worth writing down. So I'm going to list, what I'm going to do is I'm going to list all of the reasons how I know to factor this by reverse FOIL and not GCF. So yes, those numbers are correct, but I want to talk first about like how do we know to even think about that. So that's one way I know to use this method. I'm dealing with the quadratic. Another thing that I know is that they have no common factor. That really should have been the first thing that I wrote down, honestly. But these 3 terms have no common factor. It's a quadratic. And then lastly, what matters is the number of terms. And I'll put that in parentheses just in case anybody doesn't know what that means. All right. If all of these, I guess, conditions have been met, then that's how you know reverse FOIL. This one is the easiest one, or one of the easiest ones, because the setup is easy. You just got to know your times tables. That's it. When I run the stream back, I'm going to make a little counter for how many times I've said times tables. But if it's set up like this, you know that instead of distributing to check our answer like we did the last examples, if you look at like the green 6 and the 6x squared and the 4ab, we checked our answer by distributing. But with these types of answers, it's still technically distributing, but it's going to be a binomial times another binomial, as opposed to a, what do we call these? Monomial times like some other expression with multiple terms in it. So it's a binomial times a binomial. That means we're going to FOIL. And if you remember how FOIL works, you remember this first, or those two rather, they multiply to get your first term, which is an x squared. If I have an x squared for my first term, you know that I have to have an x right here and an x right here. That part doesn't even really require thought for real. In fact, y'all, like most people, I put reverse FOIL because that's what I feel like most teachers call it. But this is what I call it right here. It is kind of extra, but this is what I've called it for years, and it's probably going to stay that way. The reason I like to call it this is because if you know what to call it, then you know how to set it up. Double parentheses, x and x. Look at what I wrote so far in my answer. This is my answer, by the way. Look at all I wrote, and I didn't even think about numbers. I wrote a double parentheses, and I put x and x. I'm already halfway there. To get the rest, you just literally have to know how FOIL works. Notice that the x squared came from x and x. If you know FOIL, then you know that whatever number goes here times whatever number goes here, those two multiply to get 12. That's the L part of FOIL. And if you know how FOIL works, you know the outer part and the inner part are always going to combine like terms. And based on what I have here, they need to combine to get a 7x. How do terms combine? By pluses and minuses. So what I'm trying to say is whatever number goes here and here, they need to multiply to get 12, and they need to combine to get 7. If you can think of those two numbers, you're done. And notice, thinking of those two numbers is all the thinking that we did once I recognized the method. Double parentheses, x and x, think of your two numbers. You're good. So somebody in the chat already said it. They said 3 and 4. You just have to know your times tables enough to know that 3 times 4 is 12. And I guess technically you got to know how to add to know that 3 plus 4 is 7. That's it. How do you know that's the final answer? Again, what does it mean to factor something? It means that it is rewriting. I'm going to prove to you that it's just a rewriting. Appreciate that like, Joel. Such that the product of these two factors is the same as the original expression. How did I word that in my definition? I said the product, such that it is the product of two or more factors. Yes. So here's the proof that I got it right and that I'm done. So if I wanted to check my answer, let me write check right here. Check. Okay. If I FOILed, my x times x would give me x squared. My outer, you should see that gives me a 4x. My inner, you should see that gives me a 3x. I can combine like terms on the spot and say, actually, you know what? I'm not going to do that. I'm going to show every step. My outer, hold up, I can write that 4 better. That's my outer plus my inner. That will become a 7x. And then my last is a 3 times 4, which is a 12. So if I really, really wanted to, I could combine like terms. And if you notice, that expression is the exact same expression as what I started with. Appreciate that follow. Let's go. So that's how you do it. Double parentheses, x and x. I guess I'll do one more. I will say though, even though it's that simple, when you start to throw in negative signs, that's when people start selling. Because it's very easy to get like the right numbers, wrong sign. So to that, I just say do more of these. Watch, you'll see what I mean. So if I tell you to factor, all right, what does Copilot say? I'll pick the last one that they did. This one says x squared minus 11x plus 30. So just like I was saying, plus and minus signs, it does kind of make it a little trickier because you just got to think a little more and be a little more careful. But same principles apply. What do I notice? Again, observation skills. What do I observe in this expression? I see that x is being squared, so it is a quadratic. I see that it's a trinomial. There are 3 terms. And I see that between an x squared, a negative 11x, and a 30, they don't have anything in common. Not all 3 of them don't. So GCF is out. And all of these conditions that I just listed let me know that it's a double parentheses x and x. Double parentheses x and x. So what do? I do exactly what the method is called. That's why I call it that. Because if you know what it's called, you're literally halfway there. Literally. So from here, it's just how does FOIL work? The 2 numbers that go in parentheses, the L part of FOIL, they get multiplied to equal, in this case, 30. And then remember, the O and the I, they're always going to combine like terms. In this case, they got to combine or add up. I know a lot of people like to say add up to negative 11. Here's what I notice every year. People will say this. I'll be looking at the class. I'll write this problem. I'll double parentheses x and x, and then I'll say what 2 numbers. Or no. I'll ask them. I'll say, like, what are the 2 numbers that you're thinking of? What do they have to do? The correct answer is they have to multiply to get 30 and add up to get negative 11. But what a lot of students will say is they'll be like, you have to think of 2 numbers that equal 30. What is wrong with saying that? When you say equal 30, I don't know what you're doing to make those numbers equal 30. I don't know if you're adding them. Are you dividing them? Are you raising 1 to a power? Like, you know what I'm saying? So it's specifically multiply to get the 30, and they got to add up to get the negative 11. You can't just say they have to equal out to 30 or a negative 11, because you can do different things to make 2 numbers equal a number. You know what I'm saying? So I just had to make that distinction because I've heard people say that too many times to not bring it up. But okay. 2 numbers that multiply to 30 and add up to negative 11. Now, I will say this. If you think about it, 2 numbers got to multiply to get a positive number. But those same 2 numbers got to add up to get a negative number. If you know the only way that happens is if both of those numbers are negative. Both of those numbers that I'm about to write down have to be negative, because the negative times a negative is a positive. And then if I take 2 negatives and add them together or combine them, it's just going to get more negative. So if you're stuck trying to think of the numbers and the signs, just use that little observation to know that both of these numbers have to be negative. All right. And it just so happens that one of them is a negative 6 and one of them is a negative 5. So that's how that works. I got to remember to keep an eye on my Twitch chat. All right. I got them both pulled up. Okay. So that is double parentheses x and x. Let's do another one. I'll do one more, and then I'll do like a factoring stream part 2, where I'll just do more examples instead, because like this stream was mostly just like me teaching you how to factor. Next stream I'll do like we'll get some reps in. But all right, let's do difference of squares. It only makes sense. And I know I keep saying each method I introduce, I keep saying that it's easier, and I'm gonna keep saying it's easier. This method is probably the easiest. It's weird because this method is easy, but for some reason, a lot of students have the hardest time recognizing this method. I don't know what the deal is about difference of squares, but once a student recognizes, oh, I can factor this using difference of squares, it should take you like, bro, it shouldn't take you more than like 8 seconds to factor by difference of squares once you recognize it. So if anything, difference of squares is more or less like a recognition game. In fact, I'm going to write that down. because that is the hard part, is recognizing it. I'm going to put recognition game in parentheses because that's really all you got to do. So, difference of squares, math vocabulary, difference of squares. It's telling you what it is. Let's start with an example. So, I'll start with telling you to factor, let's go x squared minus 25. Okay, that's it. That's the expression, x squared minus 25. So it is a quadratic because remember, the hard part is figuring out which method to use. So I'm trying to kind of think through my reasoning as to which method to use. Because remember, we always want to start with trying GCF. Between an x squared and a 25, they have nothing in common. Yes. Well, technically no, because you forgot parentheses. But yes. So they don't have anything in common. It is a quadratic. However, it's not a trinomial. So here's the deal. All of those things are true. Plus, notice that it's two terms. This is probably worthy of writing down. Two terms, and of those two terms, one of them is quadratic. That does matter. Well, yeah, for right now, we'll say that does matter. And then I will say this. The terms are, this is where the word difference comes in handy. The terms are separated by a minus sign. We'll say it like that. By subtraction. Okay, once you see those, that is how you know difference of squares. Because remember, in math, the word difference means the result of subtraction. It's a binomial, yes. Yes, two terms. It is a binomial. Actually, you know what? Now that you asked that, I'm gonna change this because I like the fact that you slid that vocabulary in there. I don't know how to say your name, but I'm gonna include that in my definition because of you. So I'm gonna go two terms. I'm gonna write what that's called in parentheses. That's the change I'm gonna make. Okay, that way if I say binomial, y'all know what I'm talking about. Appreciate the follow. Okay, but like I was saying, what was I saying? Difference. It means the result of subtraction, which that is. And then if you notice, this is where the observation part comes in. Both of these terms can be rewritten as something squared. And what we call those are perfect squares. I cannot write and talk at the same time. Both terms are perfect squares. That's what I'm trying to write. Okay, so if those two things are the case, meaning it's a binomial and the two terms are being subtracted and they're both perfect squares. I know it seems like a lot of requirements, but like I said, it's a really easy factoring problem. And actually, you know what I'm going to do? I'm going to do this so that if you're watching this back, I don't just give you the answer, but you're going to come up with how easy this is. I know it's two terms, but watch what I do. I'm going to make it three terms. I know that sounds kind of like magic, but watch. If I write it like this, notice how there's an x squared and there's a constant term, but there's no x term. Watch. Okay. Still a quadratic. This time it is a trinomial. So you could, in this particular case, you could try to go double parentheses x and x. In fact, let's try it. The inventor of subtrad math puzzle books. Nice. I appreciate it. Appreciate the likes. I'll check out. I'm gonna give you a follow so I can check out your stuff after the stream. But that's what's up though. E to the I, yes. I just now seen your chat. You got to it before you wrote it before I could say it. But yes, if you do it like this, you could try double parentheses X and X, and it'll look like this. I'll just do it down here. If I go double parentheses X and X, boom, boom, same rules, two numbers. This time they would have to multiply to, and I might as well use this opportunity to say another mistake that I see a lot. If I were to ask, if I'm looking at my expression in red and I'm asking people what two numbers do I got to think of, like what do they need to do? A lot of people would say they need to multiply to 25. And that's just because we're not paying attention to the sign that's attached to the number. So they don't have to multiply to 25. They have to multiply to negative 25. That does matter. And those same two numbers, whatever those are, they have to add up to 0. So that is oftentimes not too tricky for most students because they know that numbers can be positive or negative. And so I asked them to think like, what has to be the case if two numbers have to add up to be 0? But neither one of them can be 0. Right? Because they got to multiply to negative 25. So I'm just like, how do we make two numbers add up to 0? I was like, how do you pay your debts? Like, how do you know when it's all done? Well, they're like, whenever how much you owe is how much you pay. Meaning like one's got to be negative and one's got to be positive, but they got to be the same number. So in this case, if I were to do that, it'd be like this. All right, those two numbers do multiply to negative 25. They do add up to 0. I think my teacher told me something like dots. Please explain what you mean. I don't know what you mean by dots. That could help. But difference of squares. Look at the original expression, x squared minus 25. Once we notice both of those terms are perfect squares, and both of those terms are being separated by a minus sign, you should see how quickly one could go from here to here. If you know 5 times 5 is 25. Oh, difference of two squares, dots. It's an acronym. I like it. Difference of two squares. I like that. But yeah, once you recognize difference of squares, it's that easy. I tell people, like, what do I have to square to get x squared? And what do I have to square to get 25? Notice, x times x is x squared. 5 times 5 is 25. Look at the signs in between. That's it. That's all you got to do. How do I seem like a math teacher from Texas? What does a math teacher from Texas seem like? But all right, let's do one more. And I'm not going to lie. It is a good chance your teacher's probably going to throw something like this at you. Now I will forewarn you and say this will be difference of squares. But let's go. Let's do something like that. Luke, what's good, bro? It's been a minute. But okay, this is a good example. Now, I will admit these do have factors that are in common. I could factor out an a squared. In fact, that's actually like preferred. But for the purposes of this example, I'm going to do it like this. My first term, my a to the fourth. Remember, observation game or recognition game, we're recognizing that that is the same thing as a squared. Use this to review your exponent properties. So the reason I'm writing this out is to let you know that my first term can be rewritten as something squared. And then I can also do this. I can say 144a squared is equivalent to this. 12a squared. I don't like the way that 2 looks. Oops. Okay, I could do that. Reason being, you can see that both terms can be rewritten as something squared, making them a perfect square. They are being subtracted. That makes it a dots. I don't know, Brittany, if you're still in here. That makes it a difference of 2 squares. So the answer is going to be 2 pairs of parentheses, one with a plus sign, one with a minus sign. You could do plus minus, minus plus. It doesn't matter since you're multiplying 2 things. But in the first slot of each parentheses is going to be the square root of my first term, which is a squared. A squared. It's just a thing in parentheses. And then the other slot is going to be the other thing square rooted. And that's it. That is literally it. Okay, now, to be honest, like I said, remember how I said there was a GCF to begin with? This is why I would have did it from the beginning, because if we're trying to factor this completely, both factors still have something in common. I would still have to factor out an A. You know what I mean? That's a squared plus 12a, and then the rest would have to be, I would have to factor out another a and then go a minus 12. So you can see that a squared being factored out like it was, like we could have done originally. But yeah. Okay. I guess I'll do like a couple more examples, and then next stream we'll talk about when there's a leading coefficient. Like in example 3a, if there was a number right there, next stream we'll talk about how to do that, and then we'll just do a whole bunch of examples. We might even maybe throw some trig in there too, maybe. But I'll just call these bonus problems. And we'll do some more what AI pulled up. Let's see. All right, yeah, they did a mixed one. All right, so let's do 3x squared. Actually, yeah, 3x squared minus 27x. That'll be one problem. And then the second problem will go x squared plus 10x plus 21. And then for the final example, we'll go 4x squared minus 25. Actually, no. Minus 1. Okay. Appreciate the like. All right. So, first example. Remember, anytime you factor, you always want to try to figure out like a greatest common factor first, or at least see if there is one. And if you look at both of these terms, 3 and a 7, hopefully you recognize that a 3 can go into 3, obviously, and a 3 can go into 27. So our GCF will have at least a 3 in it, but there's letters to worry about too. I got 2 X's right here, and I got 1 X right here. At the most, they have at least 1 X in common. So what I'm going to factor out is a 3X. And then remember, once I write out my GCF, I literally just write it, and then I open up a pair of parentheses. And that is where I just factor backwards. Or distribute backwards, I should say. Bober, what's good? Man, I love your Desmos videos, bro. I always try to like them each time I see them. You passed your calc class? Let's go. Did you get an A? Or did you just pass? Either way, congrats. But okay, so you're just asking yourself 3x times what? 99? Let's go. That is tough. This man knows calculus. 3x times what gives you 3x squared? 3x times x gives you 3x squared. Could you explain the nth power? If you're talking about what I was talking about earlier, yes. But to finish this problem, I got a minus sign, so I'm gonna carry over my minus. And then I'm asking myself 3x times what gives me 27x. Well, I already got the x taken care of. So 3 times what gives you 27? I believe 3 times 9 gives you 27. Yeah, 3 times 10, 30. 3 times 9, 27. So that's my answer. Notice that I do have two factors. Again, if you're just joining, remember our answer should have 2 or more factors in it. So I'm going to just highlight those 2 factors. Notice that green and yellow are being multiplied together. That's what makes them factors. And I will also say these 2 factors don't have anything in common as well. So that's worth mentioning. Okay, next problem. Remember, figure out what method. In number 1, I checked to see if there was any greatest common or any common factors. In number 2, I'm going to check the same thing. Between an x squared, a 10x, and a 21, those 3 terms have nothing in common. So GCF is out the window. It is a quadratic. It is a trinomial. That sounds like double parentheses x and x. So I'm going to literally set my problem up as such. All right. I guess I will also say, notice there's no coefficient in front of the x squared. Luke, I don't know if you're telling me that you're ready or asking me if I'm ready. But if you're asking me, no. I wish it could start next week, but it is what it is. We're here. But from here, you taught me freshman year in high school. Now I'm a freshman in college. What's good? That's what's up. Where are you about to be in school? Oh wait, I didn't mean to expose your whole TikTok. I forgot I was on stream. That's what's up though. But okay. Dang, that's been a while. 4 years. Oh, you got nice. UTA, let's go. That's what's up. Do I know linear algebra? Not like I do, not like I used to, but I was just telling somebody earlier, I want to do a day per week where I do like either Calc 2 or linear algebra or something like, higher up. But Luke, yes. She's been doing it longer than I have, so you are definitely in good hands for sure. All right, so now I just got to think of 2 numbers that multiply to get 21 and add up to 10. 3 times 6 is 18. 3 times 7 is 21. 3 plus 7 is 10. So I'm going to go boom. Oh, okay. That makes sense. Yeah, I need to get back in my linear algebra bag for sure. But okay, so that's how you do that one. Again, trinomial, 3 terms, nothing in common, double parentheses, x and x. Number 3, 2 terms, so it can't be double parentheses, x and x. Do they have anything in common? No. So it is 2 terms. They are being subtracted. It looks like difference of squares. I did this on purpose because it's obvious, but it's not obvious that both of these terms are perfect squares. So I'm going to set it up as such with my double parentheses, not double parentheses x and x, just double parentheses, a plus in one of them and a minus in the other. Do I still have the same classroom? Yes, my room is the same. It's never changed. So I'll be there. Make sure you pull up. And then I just got to ask myself, what times itself gives me each of those terms? Or if you want to do it the easy way, just take the square root of each of those terms. Majoring in accounting. Yes, yeah, you're definitely gonna have to take math, and definitely let me know, cause I'm down to help out. Cause I'm sure you got your schedule right. What math class are you taking? But okay, so for this last problem, I know 1 times 1 is 1, so I can go like that, and then I'm not gonna lie, you can just think about it. 2x times 2x will give me 4x squared. 2 times 2 is 4. X times x is x squared. So 2x times 2x will give me 4x squared. That was the ugliest box I ever drew. Boom. And then boom. If you're just just starting out with factoring, I would always suggest you distribute and check your answer just to make sure that you're correct. Do I have a class second period on A Day? Yes, I do. It's a full one too. So if that's when you have it, you'll definitely hear us because we're gonna be packed. But okay, next stream I'll do some more examples, and then by then I'm sure y'all are gonna hopefully start like learning stuff, so I can get some suggestions as to like what to go over and what not. So yeah, that's the stream. Tomorrow, I might be getting ready for first day of school stuff tomorrow, so maybe like Thursday, Friday. Good stream. Oh, you been in here the whole time? Let's go. Yes, it was a good stream. Send the playback to somebody who you know can use this, because we went over like 3 different factoring methods. Yeah, and then just like what factoring even is in the first place. So Luke, yes, hers is right next to mine, so you'll definitely hear me for sure. But all right, I'm off of here. W stream. I'll catch y'all.